Number 23 on 6-2. First of all, this is a tangent graph, so we do that totally different than anything else. We're going to take whatever follows the word tangent and set up two equations. When you want to know what these two equations are set equal to, you look back at the function. Since this is the tangent function, it's going to be set equal to negative pi over 2 and pi over 2. Then we solve these equations. What we're doing here is we are finding the vertical asymptotes. The original vertical asymptotes of tangent would be negative pi over 2, 3 pi over 2, 5 pi over 2, all the pi over 2s. We just found a set of them. So one is going to be at 0, the other one's going to be at pi. 0 is the y-axis. Halfway in between, we're going to cross over the x-axis. Since the number in front of tangent, which is a, is 1, there's no change in the curve. So the curve for tangent starts up here and comes on down through. You need to do a second period, so you can either go over here to 2 pi. Since we were from 0 to pi, it's a distance of pi, so another pi would be 2 pi. Or you can go in the negative direction, a distance of pi, to do your second period. Either one works. For number 27, we're going to graph 2 sine x, because cosecant is the reciprocal of sine. So my parent function is y equals sine of x, which looks like this. The 2 in front of the word sine is what a is equal to. A is the amplitude, so that means instead of going up to 1 and down to negative 1, I'm going to go up to 2 and down to negative 2. All of my values on my x-axis are my usual quadrant angles. So we need to go up to 2 and down to negative 2. My sine graph starts at the origin. That's not going to change. It's going to end at 2 pi. Again, not changing. All we're doing is changing how tall it is. Halfway through, it crosses over the x-axis. The first half we have a maximum. The second half we have a minimum. Again, follow this pattern in either the negative direction or the positive direction. It does not matter which one you decide to go in. Then you can connect these if you want to. What am I doing way down there, you silly goose? You go right there. You can connect these if we want to, but what we really need from this graph are the maximums, the minimums, and the midline intercepts. In this case, the midline is the x-axis. So every time it crosses over the midline or the x-axis, we're going to have vertical asymptotes. Again, I'm doing 3 periods here. You only have to do 2. And then at all the maximums of this graph, we're going to have parabolas whose vertex is the maximum of that graph opening up. And at all the minimums, we're going to have the vertex of a parabola opening down. There we go. And then the last one is number 29. So this is a secant, so we're going to graph 4 cosine 3x. So my original parent or toolkit function would be y equals cosine x, which would start up at 1, end at negative, go down to negative 1, and go out to 2 pi. The 4 here is a, so again, my amplitude is going to go up to 4, down to negative 4. This is b. That means that I'm changing the length of my graph, so I'm not going to end at 2 pi anymore. To figure out where I end, I use my formula for period, which is 2 pi divided by b. In this case, b is 3. 2 pi divided by 3, can't simplify that, so that's how far out my period's going to go. So I'm just going to make a mark on here at where 2 pi over 3 is. And then halfway in between that would be pi over 3. Halfway in between that is pi over 6. And then this would be 1 pi over 6, 2 pi over 6, 3 pi over 6, which reduces to pi over 2, 4 pi over 6, which reduces to 2 pi over 3. So we're going up to 4 and down to -4. I'm not flipping or reflecting this over the x-axis or anything, so I'm starting up at the maximum, ending up at the maximum, halfway in between going to the minimum, crossing over the x-axis. Again, you can continue this out in either the positive or negative direction. Again, you don't have to connect these points because all we really care about is where we're crossing over the midline, in this case the x-axis. And then our maximum values are where we have parabolas opening up, and our minimum values are where we have parabolas opening down.